Okay, a block B of mass 0.6 kg and a particle A of mass 0.4 kg are attached to opposite ends of the light inextensible string. The block is held at rest. Okay, so U equals to 0 meter per second on a rough horizontal table. So frictional force is involved, mu r is frictional force. And if you read the next line, it says the coefficient of friction between the block and the table is 0.5. Okay, mu equals to 0.5. The string passes over a small smooth pulley C at the edge of the table, and A hangs in equilibrium vertically below C. Okay, so at this point, as we read at this point, it's in equilibrium, so there's no motion involved. The part of the string B and C is horizontal, and the distance BC is 3 meter. Okay, B to C is 3 meter. B is released and the system starts to move. So now there's a motion. Okay, so find the acceleration, part 1 of B, and the tension of the string, and part 2, find the time taken for B to reach the pulley. Okay, let's look at the question. So first at A, okay, the mass is 0.4 kg at A, and at B the mass is 0.6 kg. Okay, that's B and that's A. Okay, now let's use the formula. Okay, when it's motion, okay, this is where the movement is, so it's moving towards right, and likewise A will be moving downward. So what happens at A? mg minus t equals to ma. Okay, I always tell the students that if the weight of the mass is pulling another object down, then the mass should be greater than the tension. So therefore mg minus t is ma. Okay, so that's how I try to logic with the students, or those who don't see the picture. So please use this method. If the mass is greater, it's going downward, then mass minus t. If it's going upward, then it's pulling the mass up, then the tension should be greater than the mg, so t minus mg. And whereas at B, okay, if you look at it, okay, the string is like pulling the mass at B, so in that case we have to use T minus, but this is not a smooth plane, it is a rough plane, so we have to minus the frictional force mu r, and that is equal to ma. Now just plug in the values given. So m is 0.4 times by 10 minus t, and this is 0.4a, so therefore t equals to 4 minus 0.4a. okay, 4 minus 0.4a, so that's first equation. And our second equation, t minus mu r equals to ma, so t minus 0.5 times by r is actually the normal force. Okay, so 0.6 times by 10, and this is equal to 0.6a, so therefore t minus 3 equals to 0.6a, so t equals to 0.6a plus 3, so that's our second equation. Excuse me. Now solve for 1 and 2. So 0.6a plus 3 is equal to 4 minus 0.4a. So therefore 1.0a equals to 1, a equals to 1 over 1, which is 1 meter per second square. So once I've got that, I can find what is t. T equals to 4 minus 0.4a, so 4 minus 0.4 times by 1, and the answer is 3.6 Newton. And for part 2, the question is find the time taken for B to reach the pulley. Okay, distance is 3 meter, we already know that's given. Okay, so that's 3 meters. T is what I want to know. U is 0 meter per second because it starts from rest, and A is, we just found that it's 1 meter per second square. So with all this information, I can use SUVAT formula S equals to UT plus half AT square. So 3 equals to that 0 plus half times by A, which is A here is 1 times by T square. So therefore 6 equals to T square. T equals to square root of 6, which is 2.449 second, and if I round that to 3 significant figure, I have 2.45 second to 3 as 7.